Okay, ladies and gentlemen, boys and girls, here we go. This is the last walkthrough for the last practice test of the last test of the year. I'll try to keep it together. I promised myself I wouldn't cry. All right, here we go. Number 1, in the reaction, the molecule H2SO4 acts as a or an. Well, what happens to H2SO4, sulfuric acid? Well, from the left to the right, it loses one hydrogen. It goes from H2SO4 to HSO4. Or H1SO4 if you wanted to look at it that way. So it donates a proton, which makes it an acid. Proton donors are always acids. A proton acceptor would be a base. Which of the following equations shows a strong acid? Well, the way to identify the one that's the strong acid, because you're not expected to memorize strong acids and weak acids by list form, is to look at the arrows. Okay, a strong acid dissociates completely, which means that reaction is not reversible. Okay, and the only one of these options that is not a two-way arrow is choice C. It only goes from left to right. It is a forward reaction only. So that is the correct choice. That is the strong acid. Answer choice C. A substance that ionizes partially in aqueous solutions and produces hydroxide ions, OH negative, is either a weak base, strong acid, strong base. Well, it produces OH according to the problem, so that makes it a base. If it produced hydrogen, it would be an acid. And it ionizes partially, and anything that ionizes partially rather than completely is weak. So this is a weak base, choice A. Number 4, strong acids conduct electricity blank. Weak acids, less than, more than, the same as, or cannot be determined. Well, cannot be determined would, first of all, be horrible grammar, but it's also not correct. Acids conduct electricity because of the number of ions in the solution. So it would follow that strong acids, which produce more ions, can conduct more electricity than weak acids. Okay, more ions, more conductivity. We're looking at choice C. In the reaction, HCl, hydrochloric acid plus water, produces chloride ions and hydronium ions. H2O is a what? Bronsted-Lowry acid, Bronsted-Lowry base, Lewis base, traditional acid. Well, a Bronsted-Lowry acid is a proton donor. It gives up a proton or a hydrogen. Bronsted-Lowry base is a proton acceptor, so it's going to gain a proton. And a Lewis base is a hydroxide donor. Well, there's no hydroxide in this equation, so we're going to rule out Lewis base. And what happens to water? Well, from left to right, it gains a proton or accepts a proton or gains a hydrogen. Same thing. So that makes it a Bronsted-Lowry base, which is choice C. An Arrhenius acid is defined as a producer of hydroxide ions, a producer of hydrogen ions, a proton acceptor, or an electron pair acceptor. Well, hopefully you'd recognize that we never talked about electron pair acceptors. That's a whole different model called Lewis acids and bases, which we didn't cover. And proton acceptors are bases, and producers of hydroxide ions are bases. Arrhenius acid is something that produces hydrogen ions. Choice C. Expression, which of the expressions below represents the pOH of a solution? Well, pH and pOH are both, first of all, the negative log. So you can rule out A and C right away. And we're looking at pOH. So it's the negative log of the hydroxide concentration, which is, so pH is hydrogen, pOH is the negative log of hydroxide. So we're looking at answer choice D in this one. Number 8, a conjugate acid is the species that? Well, a Bronsted-Lowry acid is a proton donor. A Bronsted-Lowry base is a proton acceptor. We've covered those. A conjugate acid is formed by the addition of a proton to a base. And the conjugate base is what's left over after an acid has given up a proton. So we're looking at answer choice D. Okay? A conjugate base has to be related to an acid. You need to remember that. And it's what's left over after the acid has lost its proton. Answer choice D. Number 9, a water solution whose pH is greater than 7 is, well, pH of 7 exactly would be neutral. This is not 7. pH of less than 7 means an acid. And so you can probably guess by now, pH greater than 7 means a base, so it's always basic. Choice C. Number 10, a substance that can act as both an acid and a base is triprotic, monoprotic, amphoteric, or polyprotic. Well, which of these things is not like the other would be the first question, I'd say. The A, C, and D are all about protic, and the other one is different. So that's probably the answer, but let's take a quick look. Triprotic means 3 protons. Tri means 3. Protic, protons. Monoprotic means 1 proton. And amphoteric is something that can act as a solid or an acid or a base. A solid or a liquid. An acid or a base. And polyprotic just means it's got more than 1 proton to donate. So triprotic would be also called polyprotic at the same time. Okay, what is the hydrogen ion concentration of a 0.0002954 molar solution of KOH? So this could also be written as 2.954 times 10 to the negative 4th, but it's not. Either way, a couple of things to keep in mind here. The number that you are given in the question, the concentration of the molarity, is 0.0002954, and you might be tempted to take the negative log of that number, but you would be incorrect, because that is the hydroxide concentration, and we're looking for the hydrogen concentration. So what you need to remember is that the hydrogen concentration times the hydroxide concentration is always 1.0 times 10 to the negative 14th. Always comes out to that number. So since we know one of the two numbers on the right-hand side, we plug it in, and we divide by that should be 0.0002954, which is corrected here on this slide. Good. So when you divide 1.00 times 10 to the negative 14th by 0.0002954, you get 3.385 times 10 to the negative 11th. That is the hydrogen ion concentration. All right, what is the pH of a 3.08 times 10 to the negative 4th molar hydrogen bromide or hydrobromic acid solution? Well, this time we do have an acid. You can tell because it's got H at the front, HBr. And again, you can assume if I'm giving it to you, it is a strong acid for this test. So a strong acid has the same concentration of hydrogen ions as the concentration of the solution itself, which means that the hydrogen concentration is going to be 3.08 times 10 to the negative 4th. And to find the pH, I'm going to take the negative log of that number. Okay, there's my hydrogen ion concentration. Plug that in, grab your calculator, hit negative log, and then type 3.08. And if you're on a graphing calculator, you're going to hit second E, negative 4. That's the easiest, most often right way to do it. You try to start doing times 10 to the, put the up arrow and negative 4 and whatever. You're much more likely to make an error in syntax and get the wrong answer, or get an error on your calculator. So negative log 3.08 second E, negative 4 should give you 3.51 as the pH. And just in case the question asks you whether it's acid, base, or neutral, remember this is less than 7, which would make it an acid. Number 13, what is the pH of a 9.21 times 10 to the negative 4th molar sodium hydroxide solution? Well, if you're reading this very quickly, going through this, you're cruising along, you might say, oh great, I just did this. It's negative log 9.21 times 10 to the negative 4th. And you would be incorrect, because the 9.21 times 10 to the negative 4th is the concentration of a base, sodium hydroxide. What we want for pH is the concentration of hydrogen ions, or we can do this the other way around. So we've got a base, hydroxide, and we can remember that the pH is equal to 14 minus POH, which makes this a little bit simpler, since I can easily find the POH by typing negative log of the hydroxide concentration, which is 9.21 times 10 to the negative 4th. It's in the problem. So I do the negative log of 9.21 times 10 to the negative 4th, and I get 3.04. That is not the pH. That's not the answer to the question. Don't stop there, because the question is, what's the pH? It's 14 minus 3.04, which is 10.96. That's the final answer that the question is asking. And again, there's a question that's going to be just like this on the final exam too. So always remember to check. If I'm looking for pH, am I given a hydrogen, so an acid solution, or am I given a hydroxide? Because you need to do an extra step if it's hydroxide and you're looking for pH. Okay, number 14. This one makes you do a little bit more work for a couple of reasons. First of all, it's a hydroxide solution, so I can't get the pH directly even if I was given the concentration of this solution. And I'm not given the concentration of this solution. I'm actually given the number of grams added to a certain volume. So I'm not even close to getting the pH. I've got to do some steps first. So what I need to do is first figure out the concentration, which is moles per liter. Do I have moles and liters? Nope, I don't have moles. I've got grams. I've got milliliters, which I can easily convert to liters. So first I have to get the moles. The moles is the grams given divided by the molar mass. The molar mass of KOH is 56 grams per mole. That gives me 0.0286 moles, and that's in 500 milliliters, which is half a liter. Move the decimal 3 places to the left. Now I can figure out that the concentration, the molarity, is 0.571. But again, don't move too quickly and just do the negative log of that. We do need to do the negative log of that to get the POH, which is 1.24. That's good, but it's not the answer because the question wants pH. So I have to do 14 minus 1.24, which is 12.76. That's the final answer that the question is looking for. Okay, so here's a bunch of parts to question 15, but they all ask the same question. Are these solutions acid, bases, or neutral? So, first one, solution with a pH of 4.23. This is pretty straightforward. It's giving you the pH. Is it more, less than 7, or equal to 7? It's less than 7. pH less than 7 means acid. All right, a solution with an OH concentration of 3.47 times 10 to the negative 4th. Well, I could find the POH of this by taking the negative log of 3.47 times 10 to the negative 4th, and then I subtract that from 14, and I would find that the pH is 10.5, which makes it a base because it's greater than 7. A solution with a hydrogen concentration of 2.47 times 10 to the negative 10th. Doesn't give me pH, so I can't say just yet, but I can take the negative log of that number because it is the hydrogen concentration. So negative log 2.47 times 10 to the negative 10th gives me a pH of 9.61, which is a base. So moving on, the next one has a POH of 9.9. Don't get too quick on this one. That's not the pH, it's the POH. So to find the pH first, I have to subtract it from 14, and that would give me a pH of 4.1, which makes this an acid. Part E, solution with a pH of 3.5. That is just the pH, so you just need to look at it. It's less than 7, which makes that an acid. Last couple in this part, a solution with a hydrogen concentration of 1.00 times 10 to the negative 7th. Take the negative log of that number, because it is the hydrogen concentration. Negative log of 1.00 times 10 to the negative 7th is 7. And anything with a pH of 7 is neutral. That's pure water. And then a solution that tastes sour, you have to remember back to our properties of acids and bases. Something that tastes sour is going to be acidic, an acid. And any solution that turns litmus paper red, which would be turning blue paper to red or leaving red paper red, is also an acid. If it turns the paper blue, that would indicate a base. Last couple here, oldies but goodies. And the last oldies but goodies of the year, not counting the final, which is all oldies but goodies. So how many protons, neutrons, and electrons does the isotope sulfur 3316 have? Well, you need to remember that the 16 is the atomic number, which is the same as the number of protons, so 16 protons. And since it's not an ion, it's a neutral atom, no plus or minus up there, it's also got to have 16 electrons. Those two numbers always have to be the same, and they're always the number on the bottom when you look at the notation like this. And then the number on the top is called the mass number. The mass number is the protons plus the neutrons. Well, we already know the protons are 16, so if the mass number is 33, then the number of neutrons has to be 33 minus 16, which is 17. So 16 protons, 16 electrons, 17 neutrons. And last one, a balloon has a volume of 97.4 liters at a pressure of 6.54 atmospheres. What will the new volume be if the pressure goes down to 2.54 atmospheres? So this is Boyle's law. Pressure 1, volume 1 equals pressure 2, volume 2. And I've got three numbers to plug in. I've got pressure 1 of 6.54 atmospheres. I've got volume 1 of 97.4 liters. And that equals pressure 2, which is 2.54 atmospheres, times volume 2, which is what I'm trying to find. So to isolate the volume 2, to solve for it, I need to divide both sides by 2.54, which gives me 6.54 times 97.4, and then that's divided by 2.54, and that comes out to 250 liters using three significant figures, so I had to round off all the decimal points. 250 liters. Ladies and gentlemen, this concludes the review videos for this year, and good luck on the test on Monday, and then we're getting ready for the final.